Today we're going to start our last unit on probability. Today mainly we're looking at permutations and combinations, and a lot of it is actually calculator work. Permutation and combinations arrange objects. If I care about the order, like I care about arranging things but the order does matter, it's called a permutation. For example, winners in a race or different ways letters are arranged, we could use a permutation. The notation for permutation is N, P, R. N is the number of total objects you have, R is how many you are ordering. If you arrange objects where order does not matter, it's a combination instead. For example, members of a sports team. It doesn't matter what order you pick the members on the team, they're still all on the team together. Or people to be part of a club. It doesn't matter the order you pick the people to be in the club, they're still in the club. The notation for combination is N, C, R. N is the number of total people you are arranging. R is total number of people in the group. R is the number that you care about arranging. The first piece is all calculator work. It's practice using the different buttons. The first one we have is it has a 12 and an exclamation point. That exclamation point is called a factorial. The way you get to it is you're going to type 12 in your calculator. Then you're going to hit math, arrow over to the right to PRB, and number 4 is your exclamation point. And when you type it in, you get 4 million, or sorry, a lot more than 4 million. 479,001,600. What that 12 factorial means, it's really just 12 times 11 times 10 times 9 times 8 all the way down to 1. So 4 factorial would be 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 all the way down. 6p6. So you can use a calculator for this as well. You'll hit 6, math, arrow over to PRB again. Number 2 is your NPR button, and then 6. And you get 720. And then you'll hit for 4C3, 4, math, arrow over to probability, choose number 3, and then 3 gives you 4. When you have the parentheses like that, that's the same as the combination. So it's really 15C5. So 15, math, arrow over to probability, number 3, and then 5 gives you 3003. I'll have you guys try the last one. Just type it in. Use the multiplication sign in between. It says find the number of different arrangements that are possible for the letters of the following words. This is a common question on the Regents. Now yours looks fine. Mine, you can tell the CS on statistics moved over to underneath factor, so I'm just going to cross it off on mine. The first thing you do is you count out how many letters you have. In the word factor, you have 6 letters. So you start out with a 6 factorial. Then you have to see if you have any common letters. And you don't. All the letters are unique, so it's just a 6 factorial. So then you type it in. It's going to be math, or you're going to hit 6, and then math, arrow over to probability, and number 4. And it'll give you 720. That means there's 720 different ways to arrange those letters. Now for divide, I see I have 6 letters there. However, this time I see that I have 2 D's. So I need to divide by a 2 factorial since I have 2 D's. I also see I have 2 I's. So I need to divide by another 2 factorial. There is a multiplication sign in between. When you type this in your calculator, you have to use parentheses in that denominator. This was a question very similar to one on the Regents last year. So you just have to make sure you type carefully and you get 180. You guys are going to try the other 2. Just count out how many letters you are over the common ones you have. Just remember statistics does end with a C and an S, but you should have that on your paper already. Alright, so a couple word problems. Determine the number of different arrangements. The finishing order of 7 runners in a race. So you have to first decide, does order matter? Do you care if the runner comes in first or 7th? You should be saying yes, order matters. So since order matters, am I using a permutation or a combination? Well, if you look back at the top, it's a permutation. So you have 7 runners all together, and you want to order all 7 of them. So it's 7P7 in your calculator, which is 5,040. Seating 5 students in a row of 9 chairs. This one might be a little harder to decide if order matters or not. But pretend you're the teacher. Do you care who sits next to each other? You would probably say yes. You don't want best friends who talk all the time sitting next to each other. So I'm going to say yes, order matters. The total number I have is 9 chairs. And since order matters, I'm going to use a permutation again. But I want to only order 5 of them. So 9P5, type it in your calculator, you get 15,120. Next one, Eli has homework assignments for 5 subjects, but decides to complete 4 of them today and the 5th before class tomorrow. How many different orders can he choose 4 out of the 5 assignments to complete today? That tells me order matters. So I'll use a permutation again. I have 5 subjects altogether. I want to order 4 of them. So it's just 5P4, which is 120. The next one, there are 12 boys, 13 girls in a class. How many ways can 2 boys and 3 girls be selected to transfer to a different class? So right now you're in my E2 trade class and I say, all right, I need 2 guys and 3 girls to move over to my other class. Does it matter whether I pick boy 1, boy 2, or boy 2, boy 1? They're still going to the same class. It doesn't matter the order I pick them in. They're still moving. So since order doesn't matter, we will use a combination. We do need to separate boys and girls. So we have 12 boys altogether, and I'm going to choose 2 of them to go to another class. And I have 13 girls altogether, and I'm going to choose 3 of them to go to my other class. It will be combined with a multiplication in between because I want boys and girls to go to another class. When I say and, it's a multiplication. If I said or, it would be an addition. So you type that in your calculator and you get 18,876. And I want you guys to try the last one as well.